Hi there, and I'm going to be discussing seagrasses and the direct and indirect impacts of climate change. Seagrasses, or Zosteraceae, are flowering marine plants which are distributed widely along tropical and temperate coastlines. There are currently around 72 species, 11 genera, and 4 families found in shallow estuaries, bays, and lagoons, forging dense meadows along the seabed. Current studies have determined that seagrass cover approximately 1,646,788 square kilometers. Whilst they receive very little attention, seagrass meadows are one of Earth's most productive ecosystems and have fundamental influence on biological, physical, and chemical mechanisms, providing infinite and crucial ecological services to the marine environment. Seagrasses have a crucial role as primary producers for the overall productivity of their environment. Chloroplasts in their blade tissues photosynthesize by utilizing the sun's energy to convert carbon dioxide and water into sugars and oxygen for growth, which in turn increases oxygen concentrations available for other organisms. Minerals and nutrients are transported to the rest of the plant via the veins and the roots. A diverse community of marine species depend on seagrasses for food, refuge, and nurseries, including for adjacent habitats such as coral reefs, mangrove forests, and salt marshes. In turn, having substantial economic influence by supporting important tourism industries and commercial and recreational fisheries. Seagrasses are also a pivotal food source for critically endangered species such as the dugong, manatee, and green turtle, who in return expertly engineer and structure the ecosystems, increasing and supporting biodiversity. Seagrass meadows also play a key role in decelerating marine currents, trophic dynamics, reducing coastal erosion, and improving water quality through nutrient cycling, sediment stabilization, and accumulation, and by filtering marine plastics. Astonishingly, research has since determined that seagrass meadows can sequester double the carbon concentration and at 35 times faster than tropical rainforests. This deems them a crucial ally in global efforts to combat climate change. Seagrass meadows have high primary production rates, while decomposition rates in the seagrass sediments are rather low. This creates an effective long-term carbon sink. Thus, seagrass meadows can be regarded as autotrophic ecosystems, releasing a substantial amount of oxygen while intensively sequestering carbon dioxide. But these vital submarine oases are under severe threat all over the world, with scientists stating that meadows are declining at an unprecedented rate due to sustained anthropogenic pressures, water quality diminishment, the impacts of climate change. Seagrasses have been decimating at a rate of 7% annually, with species now being listed in the IUCN. This means that they are now classified as one of the most rapidly declining ecosystems on Earth. So, how does climate change affect seagrasses? Well, the ocean typically absorbs around 80% of excessive heat, and consequently, global ocean temperatures have increased dramatically. Marine heat waves, extreme weather events, rising sea levels, and eutrophication all have implications on seagrasses. Temperature is typically the most vital range-limiting factor, with increased temperatures resulting in depletions of dominating macrophytes along their extensions into polar regions and equatorial ranges. A marine heat wave is defined when seawater temperatures exceed a seasonable varying threshold, usually the 19th percentile, for at least 5 consecutive days. This results in impaired carbon balance, photosynthetic injury, climate-mediated alterations in diseases and herbivory, which can all lead to major mortality events and the collapse of entire seagrass systems. Depletion of seagrass canopies can expose the soil's organic carbon stocks to hydrodynamic forces, which in turn result in the rapid erosion and remineralization of ancient stocks of CO2. and as a consequence of habitat degradation and increased seagrass decomposition, the organic sea stored in the sea meadows can be emitted as CO2 back into the atmosphere. Ocean acidification, the decrease in seawater pH due to increased dissolution of atmospheric CO2, is an additional climate change stressor, which is expected to impact habitat-forming species with cascading effects encompassing the entire ecosystem. Increased wave magnitude from frequent storms and flood events deplete seagrass distribution through the destruction and uprooting of well-established plants. This in turn prevents the settlement and regeneration of seeds. Currents driven by tidal and river flow alterations generate high physical forces, causing major turbidity and in turn impeding seagrass's photosynthetic activity due to the reduced light availability. Glaciers melting and warmer waters expanding the volume oceanic waters cause rising sea levels, changes in tidal variation, increased water intrusion into estuaries, and shoreward migration in seagrass. Light availability influences seagrass distribution due to the lack of light with increased depth. This causes failures in growth, biomass, morphology, and physiology, with plant communities may be declining and may be eliminated as a result of increased disease activity under more highly saline conditions. Conversely, experts say that marine macrophytes may benefit from the increased CO2 concentration since their photosynthetic rates are often sea-limited. Studies with Zostera and Thalassia showed increased primary production, growth, and shoot density under increased CO2 availability. So, what are the effects of the loss of seagrasses? Seagrass losses disrupt important linkages between seagrass meadows and other habitats, and their ongoing decline is likely producing broader and longer-lasting impacts than the loss of the meadows themselves. Losses of seagrass meadows will continue to severely reduce the energy subsidies that they provide to other ecosystems. This includes coral reefs, mangrove forests, salt marshes, and even the deep sea, diminishing the overall net secondary productivity. Trophic cascades will follow, with the loss of critically endangered species causing tourism and fishery industries to collapse further. Most importantly, humans will lose one of their strongest allies in climate change mitigation, as the loss of seagrass meadows will dramatically reduce the percentage of carbon sequestered by the marine environment. We require an integrated approach including efforts to avoid excessive aquaculture, reduce nutrient and organic inputs from urban and agricultural sources, and reduce sediment loading. Mechanical damage through anchors, propellers, and fishing gear must be avoided, and optimal growth conditions should be prioritized so we can arm seagrass meadows with the resilience and resistance they need against the relentless pressures of those attributed to climate change. Additional necessary actions are the application of extinction risk assessment, boosted investments in improved water quality, redesigned boating infrastructure, regulation of damaging fishing activities, and direct restoration efforts such as Project Seagrass, Project Posidonia, and Project Seagrass Ocean Rescue through the cultivation and replanting of millions of seagrass seeds. Thank you.